Hello everyone, my name is Asisipho and welcome to my YouTube channel. In today's video, we are going to be answering three monohybrid cross questions from previous question papers. So we are going to be doing these crosses, guys, and I will take you through step by step and basically show you how you need to do the crosses in order for you to get full marks. I will break down the question, explain how we mark the crosses, and also tell you more about mistakes that you need to avoid, because obviously those mistakes may um, lead you to losing marks. So we don't want you to lose marks. We want you to get the full 6 marks. So let's do the questions together. I will firstly start by breaking down the question. And I think after I break down the question, please pause the video and attempt to do the cross yourself. Then when you're done doing the cross, you can obviously play the video to just check um, if everything that I've explaining or how I've done my cross is the same or similar to how you've done yours. That's how you're going to learn. So it's not just about playing the video and waiting for me to give you all the answers. I want you guys to learn in this channel, and I want you to do well at school. All right, so please subscribe to the channel if you haven't already. Like this video, share it with your schoolmates and your classmates, and also comment down below. So in our first question, and I am going to, just to say this, I am going to spend a bit of time in the first question because I'll be explaining a lot of things, especially terminology and how you need to break down each question for you to basically find it more easier to answer. But I won't spend a lot of time in the next two questions. So when you get a scenario for a monohybrid cross, you obviously need to break it down to understand the gene or the trait that they're talking about, and also the alleles. And also determine if it is a complete dominance kind of a cross or incomplete dominance. You actually get to understand everything, but I will speak about the types of dominance at a later stage. Okay, so what we're having here, we are having a trait for hair length. So they're telling us that in cats, the allele for short hair is dominant to the allele for long hair. So that is very important information, guys, because they are telling us the gene in question, and they've also given us the alleles. Okay, so what we are basically having here, and you need to break it down, and you can write this. You won't be penalized when you write this in your answer sheet. This is basically you breaking down the question for yourself in order for you to understand. So the trait in question here is hair length. We are looking at the length of the hair for the kids. And the alleles here is short hair gene. So you're having short hair and long hair for the cats. Okay. They're also telling us that the short hair gene is dominant over the long hair. That means the short hair gene is the dominant one over the long hair gene, which means it is recessive. And they've also indicated that by using the different sizes of the letter, we know that a dominant gene is going to receive the capital letter and the recessive gene is going to receive the small letter. Now, you can also include that when you're answering here and basically just breaking down your information, that the short hair is having the capital letter H and the long hair is having the small letter H. Now, another information that I can obviously try and help you when you're breaking down the question is when we talk about the gene that is dominant. So if we're to look at a cat and we look at the phenotype, and in this case, we're talking about hair length. If a cat is having short hair, there's two possible genotypes for that particular cat for the trait in question, which is the hair length. Since the short hair is dominant, right? So the possible genotypes for short hair would be two capital letter H's. So that would be a homozygous dominant short. That's the first possibility. Another possibility of a genotype would be the heterozygous condition for short, whereby you are having two genes, two different genes here. So it will be a short hair gene and a long hair gene. And in this condition, we say it is heterozygous. We are having hetero means different. You're having different genes. But again, the cat would still be short here. in this case because the short hair gene is dominant over the long hair gene. So here this condition is known as homozygous dominant. Homozygous dominant. Now what we're basically saying here is that the genotype is having the same gene. This is a short hair gene and this is a short hair gene in this particular genotype. So there's always two possibilities, right, for the gene that is dominant. Now, for the gene that is recessive, which is long hair, there's only one possibility since it's recessive. So if a cat has long hair, there's only one possible genotype. Obviously, we don't see the genotype. We are just seeing the hair length, which is the phenotype. All right. Now, let's look at the question. So the question is saying we are having a short-haired cat. So now they're giving us information about the parents. So this is parent 1. I'm going to write P1. So parent 1 is a cat with short hair, and we're going to cross that with the second parent P2, which is having long hair. Now let's get to understand the question exactly. They're saying we must do a genetic cross, and in this genetic cross we must determine the percentage chance of the offspring being heterozygous. We are trying to find out the percentage chance of the offspring being heterozygous, meaning of the offspring actually being heterozygous short. We need to answer that question at the end. So in terms of the cross questions, they might ask you for the percentage chance. They might also ask you for the ratio. So you need to read the question and get to understand exactly what they are asking from you. Now let's do the cross. Now, when we're doing the cross, remember guys, there is a sequence that we need to follow when we're doing the cross. And the first thing is that we write P1, which is going to give us more information, or we are basically giving information about the parents. Okay, and when we talk about the parents, we first need to indicate the phenotype of the parents, and the phenotype in question is the hair length. Now, they've told us that parent 1 has short hair. So this is a cat with short hair, and we are crossing that cat with one that has long hair. Now, in order for you to then give us the genotype, that's what you then indicate just below the phenotype. Now, the genotype for parent 1, which has short hair, is the heterozygous genotype, which is capital letter H, small letter h. Where did we find that information? They've given us here. They've said the short-haired cat that is heterozygous. It is crossed with the one that has long hair, and this is the genotype. Small letter h, small letter h. After that, we then indicate that meiosis will take place and these genes are going to be separated. When they are separated, sihlukanisa nje just the letters. We're just segregating or separating the letters in our case. So small letter h, small letter h. Now these are genes that we're then having in our gametes. We then say these are our gametes, are indicated by these letters. Fertilization will then need to take place, and there's two ways of indicating fertilization taking place. You can do the normal crosses or you can do a punnett square. You do not have to do both. You just need to choose which one works for you. Now, a mistake that some learners make, they end up crossing gametes of the same parent, and this is incorrect. So you cannot cross out these two gametes. You cannot cross out these two. You will cross out gametes from different parents. So gametes from parent 1 will need to be crossed out with gametes from parent 2. That is how fertilization takes place. Think of a sperm cell fusing with an egg cell. You cannot have a sperm cell fusing with a sperm cell. Get it? Yes, ma'am. Okay. So this H will then be crossed out. The first gamete from the first parent gets crossed out with a gamete from the second parent. So capital letter H, small letter h. Capital letter H, small letter h. Sorry, second gamete from first parent, first gamete from second parent. There you go. That is fertilization. Okay, now there's a lot of information I can obviously explain about this section, but there's absolutely no need. So if you don't want to do the crosses, you can then do the punnett square, And in the Punnett square, there's also different ways of doing the Punnett square, but this is very basic and you'll still get marks for it. Okay, so the sides of the square that you are going to focus on is the top side and the left side. So in the top side, you then write gametes of parent 1. So I'm going to change my color. So gametes for parent 1 will then go to the top side, and these gametes for parent 2 are then going to go to the left side. So gametes for parent 1 is a capital letter H and small letter h, and gametes for parent 2, it's two small letter h's. You cross them out together, you will still get, you will still get the same genotypes that we got. Okay. Just make sure that your letters are easily identifiable, hey? So this should look like an H and not an N. Okay, so the answers that you have here, the genotypes that you have here inside the Punnett square are the same genotypes that you have here at the end, which are the genotypes for the offsprings. So you then need to indicate F1 to show that we are now having the genotypes of the offsprings, and we're now going to talk about the offsprings, okay? So you then write genotype, and you need to know that the genotypes that are the same, you need to group together. So if genotypes are the same, you need to group together and tell us how many are those genotypes, right? In the offsprings. So what we can see here is that we are having 2 of capital letter H, small letter h, and 2 of small letter h, small letter h. So you indicate that it's 2 of capital letter H, small letter h, and 2 of small letter h, small letter h. You're not done. You still need to tell us the phenotype of these offsprings. Okay? So now the phenotype also, you need to group together. So if you are having, so for example, in our case, you can go back to what you've analyzed here on top. So the gametes that we're having, sorry, not gametes, genotypes, sorry. The genotypes that we're having here in our offspring, it's 2 of capital letter H, small letter h. Obviously, this is for short hair. And 2 of small letter h, small letter h, this is for long hair. So this one is simple because it's grouped together already. So you need to indicate that you're going to have 2 cats that have short hair and 2 cats that have long hair. You group together, guys. You won't say one of this, one of this, one of this, one of this, because in our case, we're not having one of each. We're having 2 of long hair and 2 of short hair. So 2 short-haired cats and 2 long-haired cats. Now again, you can't just write 2 long and 2 short. That's incorrect. What are we talking about? We are talking about hair length. You need to be specific. And it's hair length of what exactly? Is it of human beings? Is it of dogs, cows, and whatever? You need to indicate that. As much as we are done with the cross, guys, we actually have not answered their question, because they're saying we must use a genetic cross to determine the percentage chance of the offsprings being heterozygous. What are the chances in terms of percentage of the offsprings being heterozygous short? Let's look. How many offsprings do we have at the end? We're having 4 offsprings. Out of those 4 offsprings, we're having 4 offsprings. Out of those 4 offsprings, there's 2 offsprings. Only 2 are heterozygous short. You multiply by 100, you get your 50. So you don't have to write all of this in a test, but you then have to say, therefore, you are answering the question. It is a 50% chance of heterozygous offsprings. You write that, of heterozygous offsprings. Now, the next part, I'm showing you how we mark a cross. Okay, so most of the time there will be a specific question in a cross like this one. So if you've answered the question, you then get a mark. This is known as the compulsory mark. Okay, so we are going to mark the compulsory mark plus any 5 marks that you will be given. Okay, and the 5 marks can be you writing the phenotype and the genotype, and the genotype for the offsprings, the phenotype for the offsprings. Another thing is you just writing P1 and F1. You actually getting a mark for writing both. Another one is for writing these words, meiosis, gametes, and fertilization in that order. You then get a mark. But you need to make sure that the word meiosis is showing us that meiosis takes place. And there is a segregation here of the genes. Gametes, you need to obviously make sure that this word gametes is in line with your gametes. Fertilization is in line with fertilization. This is showing us that fertilization is taking place in order for you to get full marks. I think, guys, I've explained everything. If they had asked for a genotypic ratio, this would be, is obviously 2:2, then you simplify it and say 1:1. So genotypic ratio would be 1:1, and phenotypic ratio is still 2 and 2. It would be 1:1 because you have to simplify it. All right, let's move to the next question, guys.